My name is Frank, and this is PothOnProgramming. Welcome to part 16 of the Stay Down devlog. In this video, I'm going to show you how I implemented these features and techniques in the game. I'll talk about making a game state manager, adding a title screen, loading JS files in any order to avoid dependency issues, separating initialization from the main framework methods, improving maintainability with reusable functions, adding text box graphics, and an update to the controller object. And finally, I'll talk about an important lesson I learned prior to this episode. Before we get started, I have to point out that I'm changing the format of the devlog. Going forward, I'll be writing less code on screen and focusing more on the key features introduced in each entry. For those of you who have been following the series, I hope this is a welcome change. As always, if you learned something, like the video, and of course, subscribe for more videos. You can also visit my website, which is linked in the description, where you can see all my projects and support the channel. Now let's get started. Alright, so the first thing I want to talk about is the state management tool. Now, I had a state management function which was called change state originally, but I have since migrated that over to its own object with its own function to just change a state. And I've introduced a new parameter to pass a message between game states whenever you're changing states. So obviously I've got a title screen state now, which is pretty cool. I've got a run state and I've got a pause state. So I'm also going to introduce a transition game state. So we're getting a lot of states, and we're going to have a way to pass information between states to do different things when we're starting up, say, the run game state from the title screen or the run game state from the pause screen, which does two different things. When you pause the game, we've got everything in motion in the run game state, and we want to kind of just maintain that. When we unpause, we want everything to pick right back up where we left off, and that's exactly what it does. But when we go back to the title screen and quit the current game, we want things to reset. So when we come from the title screen into the run game state, everything resets. When we pause, it kind of maintains, and I'll show you one more time if you just kind of look and see where everything is on the screen. If I hit Q to go back to the title screen, then hit P, everything resets from the bottom. Now the way this is working is with this message parameter. If we go to the title screen, and the update function, which is the function that runs all the time in the main game loop, we can see that whenever the P key is pressed, we're going to change the state with the state object. We're going to say state.change to the run game state, and we're going to pass the message reset. And what that does is inside of the run game state, when we activate the run game state, let's see where that's at. It takes a message parameter, and we're going to say if the message is reset, we're going to reset the game. And we just have a method to reset that sets all the platforms down at the bottom, sets the player back in the position where it's supposed to be. The diamond actually, I think, still stays in the same place, so I need to update that. But basically, we can reset the game, and we can pass messages into our other game states, which is really important going forward. So let's take one more look at that state manager and just kind of go over how it works. So I'm using two methods that I take from the, I guess I'm going to start calling it the main framework. It's basically this main.js file, the staydown.js file right here. Basically it has a bunch of objects that contain all the information I need, and it's got a bunch of functions to access those objects. So I'm going to be using the set tool and the set state, or the get tool and the get state methods, just to get different tools and get different game states inside of the state manager object. So I've got these two functions. When I call change state, I'm going to pass it the name of the state that I want to change to. And I'm going to pass the message that I want to activate that state with. If a state already exists and we already are currently in a game state, like right now the game is currently in the run game state, the run game state is going to be stored inside of the state local variable, which is kind of local to this state management object. So when I call change state, I'm going to see, does the state already exist? Are we already in the run game state? If so, deactivate it. And the deactivate method is just going to turn everything off regarding that state. If I have event listeners, it will remove them. If I want to destroy anything or destruct anything of that state, I'll do it in the deactivate method. Then I'm going to set the local state variable equal to the new state that gets returned by the get state method when I pass the name in. So I want to get the run game state. I've got name is equal to run, perhaps. I want to get the run game state, store it in the local variable, then I want to activate it with the message, and then finally I want to get the engine and I want to set the state inside of the engine. And this is how, if we go to the engine, where's that at? If we go to the engine, it also has a local variable for state. Basically, it just uses the states update and render methods. So technically, you don't have to pass in the state itself. You could just pass in the update and render methods. I've chosen to pass in the whole state and then use those update and render methods because one thing all game states should have in common, at least for my purposes, are these methods here: an activate, deactivate, render, and update method. So all my game states have these methods, even if they don't use them. It's kind of like a type definition. The game state type, if I were using TypeScript or a strongly typed language, I would have a class for game state, and that class would always have an activate, deactivate, render, and update set of methods. So every game state returns these methods, and that's how I know they're safe to use inside of my state manager tool. So that's basically how it works. Being able to change states is really important in a game. It brought this game from just being this one screen that you just jump right into to having, a lackluster title screen and run game state and pause game state. So pretty cool stuff. So I've talked about the title game state a little bit already, but I just want to go over it in more detail in this segment. So it's a big feature, it's a big addition to the game. Title screen is important for any game to have, even if it's super simple, and this one is super simple. It's no moving parts, nothing is even rendering on every frame. I draw this once to the screen and then that's it. It's there for the duration of the time you have the title screen up. So how this works is everything is set up in the activate method of the title game state. So remember we were talking about the change state method in the last section? That calls the activate method when the game starts up for the title game state, because that's the state we're starting on. Basically, we just get the text buffer, we resize it so it covers the whole screen. Really, we only need to resize it to cover this area. Then we use our text tool to write to the text buffer. We just write basically the text that you see here on the screen. Then we're going to get the display buffer, which is the main buffer on the screen, and we're just going to draw everything to it. So first we're going to draw the background, which is set up in the initialize function. The background just has all these tiles pre-drawn into it, so we just have to draw the big canvas one time to the screen that has all those tiles pre-drawn in it. Then we're going to draw the Dominique image, diamond image, and finally the text buffer that has the text in it. So we draw all this once in the activate method. Then when the engine is actually running and firing the render method and the update method on every frame, we have nothing to really re-render because everything is already rendered. And even if I resize the screen, it doesn't really matter because I'm resizing with CSS, so I don't even have to redraw to my display buffer or my display canvas when I'm resizing the screen because the CSS takes care of that. So this is cool because no rendering, no CPU usage really when you're on the main title screen. The update method, all it does is check to see if the user is pressing the P key. If the user presses the P key, we say change the state to run and pass the reset message into the run game state so it knows to start off fresh, basically starting a new game. And that's pretty much it. That's all I got to say about the title screen. Really easy to set up and super simple to implement more game states this way. So now I'm going to talk about files being interdependent and how that can cause a problem for you with at least organization for your project. So for me, this has always been a pain point because I hate having to order these files that I load in. Just for one thing, I love everything to be in alphabetical order, and I know that's not the case here, but in order to put everything in alphabetical order, you have to sequence your files in a way that might not be the best way for their dependencies. And what I mean by that is you certainly have run into a situation where you have a class, like an item class or a player class or an enemy class that inherits from some other class like rectangle or position or enemy or controllable player. So the order that you load those files in matters because my item class here inherits from the rectangle 2D class, and that means I have to load the rectangle 2D class before I load the item class. So the order I load these files in matters, and we could take a look at that right now because I haven't actually fixed this yet for these particular files here. I've fixed it for other files, but not for these. If I go ahead and move the item file above the rectangle 2D file and I save and I refresh, it's going to give me an error that says rectangle 2D is undefined. Now obviously the reason for this is because I'm trying to get the rectangle 2D definition inside of this file right here. So when this file loads up and executes, it's going to try to get a definition that hasn't been loaded yet. So obviously that's a problem and we can't do that. But if we really want to do that, we can. And the way to do it is pretty simple. So in my item file, I'm calling an anonymous function as soon as it loads right here. So you can see I'm calling this anonymous function. If I didn't want to do this, what I would do is I would just make this no longer anonymous. So I would pass in just a function as a constructor to wherever I'm storing all my constructors for reference later on. And what this is going to do is when this, I'm pointing to the screen, but you obviously can't see me where I'm pointing. What this is going to do is when this file loads up, it's going to define this function, but it's not going to actually require any of these definitions to be made yet. So you're going to be able to call this function, which is going to pull in these definitions at a later time after you load everything, which means you can load up all your files in any order without worrying about interdependency. Now how you set this up is a little tricky, but it's doable, and it basically allows you to load your files in any order, which I thought was really cool. So obviously this isn't going to work for this one right here because I haven't set up everything else, so I'm going to set this back to the way it was and fix it probably before the next video. But I just wanted to show you guys that, and I'll even show you the state manager because it uses all my tools now use this approach. I've converted all my tools from files that just return an object when the file loads to returning a constructor function that returns that object when you call the constructor. So before, this would have been a self-calling function that would return an object with this method inside of it. The problem with that is if it was dependent on any other definitions to create this object, I would have to be careful about the order in which I load the file. Now I don't have to be. I can come in here and I can take my state manager and I can define it. Well, I can define it anywhere because it's not really dependent on anything else besides this file. But so this is a bad example. But if you use this approach for stuff like your actual classes that are dependent on other things, it will work pretty well. And the reason is you're loading everything up here, you're just defining those functions, and then later on in an initialize method you're going to actually set that stuff up. So here's where I'm actually creating my tool objects. So when I create the state object, I'm getting the state tool constructor, which I define here, and then I'm going to go ahead and call it, and that's going to create my object. So any dependencies that I had in there would be pulled in when I call the function, and I choose when to call the function. So in my initialize file, which I'm going to go over soon, I choose when to call the function, so this way I can load the files in any order I want and then kind of compile everything, compile it. This is JavaScript. I can choose when to use those definitions later on in a way that is aware of dependencies. Another thing I want to talk about for this is if you're using the approach I'm using where you have an overarching framework object that is responsible for storing all of your constructors, all of your canvas buffers, all of your images, all of your game states and tools, this file with all of its important methods is going to have to be loaded first. So you can see that I've loaded that file first up here. Everything else technically should be able to be loaded in any order. Afterwards, you have to call another file to initialize things, and that's where you're going to be actually calling those constructor functions with dependencies in them. And the important part about the initialize function is it has to be called last, because when you call those functions they do have those dependencies and everything is going to have to be loaded. But the cool part about this is as long as you have this at the start and this at the end, the stuff in the middle can be in any order you like. So just wanted to talk about that because I thought it was pretty cool. Now I want to talk about some changes I made to the main file, which now I'm going to be referring to as like the framework file, because it kind of offers an overarching set of methods and object containers that the entire project is going to use quite frequently. So I've got a really clean looking file here, I think, and it just has some simple methods to get objects from these object containers and set objects to these containers. Everything else, all the functionality like the change state function, we talked about what I did with that earlier. I moved that out into its own object. The initialize method, which was taking up a huge number of lines, not huge, but probably like 20 or 30 lines or maybe 50 lines, just taking up a big chunk of the screen, and it kind of detracted from the clean, organized look of this file. So I separated that out into its own initialize file. So this is the initialize file where everything is actually built. So you can think of this file as where you're actually like compiling everything, where you're pulling everything in that has dependencies in a specific order and you're building it out. This way, we touched on this in the last segment, but you can load everything however you like in any order you like, and then in this initialize method you can put everything together in the order it needs to be. So for example, if you have a base class and a child class, a parent and child class, you would construct the parent class in here, and then you would construct the child class. Sort of stuff like that. You would do it in the order that matters. Another reason that I did this was because I had the way I was calling this was I would load up my staydown.js file, which is going to create this object called staydown, and then in my HTML, in the script in the body, I would just say staydown.initialize, calling a function defined on the staydown object called initialize. Now what I didn't like about this was there was always going to be this method on the staydown object for initializing, but you only ever initialize one time, and then you can garbage collect that function. It doesn't need to be there ever again until the next time you load up the page. So the way to combat this was to move it out into its own file with a self-calling anonymous function. Now this anonymous function should be garbage collected. The script tag is still going to live here, so I'm not sure how that works, but this initialize function is no longer going to be hanging out inside of my staydown object. I'm never going to be able to call it again. It's not going to clutter my screen again. It's its own separate thing, an own separate file, calls itself, hopefully gets garbage collected after. And the most important thing, I think, is that we're getting a much cleaner, more organized look of the main overarching framework which everything uses, which is very important for just keeping things organized and maintaining things and making changes going forward. And then in the initialize method, we have everything to do with setting things up for the game. So we're going to be setting up the buffer, all the buffers for the game. So like the background buffer, the display, the spikes, like the spikes at the top of the screen when you actually go to play. We're going to be drawing all these spikes to this little buffer that gets drawn across the top of the screen. The text buffer, the text box, which is new. Down here we're going to be defining this buffer, which is just a region along the bottom of the screen that we fill with graphics. So we're setting all that up here. We're going to be setting up all of our tools. All the tools now have their own constructors that return the actual object that is the tool that you use. So we're going to be calling all those constructors here to set our tools. We're going to be setting our states the same way. And whereas it doesn't matter what order you load those things up in the HTML, which is cool, it definitely matters here because things like the run game state are obviously dependent on the controller already being defined. So this is where dependencies matter because you're loading everything in an order that is aware of those dependencies. So have to define my controller before I define my game states because all my game states use the controller object. So that's another cool thing. I have to worry about that here. I don't have to worry about it anywhere else. And that's kind of the purpose of this file, just to set everything up once, worry about it once, and then it's out of the way for the rest of the game, and you don't have those methods cluttering anything else. Another thing that I did was I moved the resize method out of the individual game states and into this initialize method. And this might change later on depending on if I have different resize methods that I need to use, because I would have to remove the event listener for this resize method and replace it with one for another one. But as far as I can tell in this game, I'm only going to have one resize event listener, and it's always going to resize the screen the same way, because this little square region where the game plays is, I mean, for my purposes, it works just fine for all the different game states. And I don't see that changing going forward. So I just define the function once here in initialize, and I add it with this event listener. So now I no longer have to look at duplicate resize functions in my pause, run, and title screen game states. So that's pretty cool. What else can I go over here? Like I said, all the buffer setup happens here. So you don't want to have these functions sitting around when you're only going to set something up once. You just want to call it once and get it over with. So I figured I'd just throw this stuff in here. This is just setting up the buffers for the background. We're going to set up the spikes in the spike buffer, draw all those. Setting up the text box buffer. This draws the graphics for the text box right here. And so on and so forth. And finally, at the end of initialize, we set our state, so we get the state tool and we change the state to the title screen, and then we're getting the engine tool and we're going to start the engine. So that's basically it. I made these changes to clean things up, and as you can see, I don't know, maybe you don't like it, but I really appreciate how clean this is, and I also appreciate how this is an anonymous function call that only happens once instead of being an initialize function that sticks around on my main stay down object throughout the whole course of the game. So just wanted to go over that, see if maybe you guys thought it was a good idea, wanted to use it in your own project, because I thought it was pretty cool and handy. Now this part might seem extremely obvious, reusing functions for code maintainability, like that's obviously what functions are designed for, but the way I went about it is a little different, and I wanted to show you guys that because it's hopefully going to be a good idea and work for the duration of the rest of the project. So what I've done was to store methods that I'm going to be reusing across my different tools and my different game states and stuff like that. I created this container called methods and a couple functions, get method and set method, which I use to just add methods to that object container. And I'll show you a really simple method that I created. It's the only method that I've created so far that I'm adding to that container. I'm planning on adding more, obviously, otherwise I wouldn't have a container, I would just have this function. So basically, I'm just going to create a method called resize buffer. I'm going to set it with the set method function and store it inside of that container that you saw. And it's just a function that takes a canvas context, which I'm calling a buffer, and it sets the width and height and the smoothing, the image smoothing enabled property of that canvas. Now the reason I created this function was because in my game states, particularly the run game state, but I guess any of the game states, let me see if I can find it. If I go to the run game state, inside of the activate method, I was resizing the text buffer because the text buffer in the run game state is just this little tiny area at the bottom. It doesn't cover the whole screen. Whereas in the pause game state, the text buffer actually covers the entire screen because I was super lazy. I could have made it this size, but anyway, the point is I'm resizing buffers. Now, instead of having all of this everywhere, every time I need to resize a buffer, obviously I can just replace it with a function. So instead of seeing this in my code, instead of seeing a single line that calls a function in my code, I was seeing basically this. And I was seeing this in a lot of places, and obviously one line is better than three, so I replaced it with this. And I just wanted to show you this approach because I thought it was a pretty cool modular way to keep your files for your functions separate and just keep things really organized and easy to look at, because it's so much easier to just go into a single file that has this really simple function in it than it is to go into my main.js file and have like a ton of functions in here that kind of just get in the way of finding what you need to look at and distract you from what you're actually working on. So this was just a cool way to import functions to use wherever you want. And let's take a look real quick at the way we're actually importing things. So remember, we have our main overarching stay down object. We have the get method on this object, which basically just pulls something out by its name from the methods container. So if we come into the run game state, up at the top, we are going to be pulling in the get method, and then we can use this to get methods by their name wherever we want. So down here, I'm just saying get method resize buffer, and then you do the function call and pass in the parameters right after. And the cool thing about this is I'm using this inside of the run game state. I'm also using this inside of the title game state and the pause game state. So it's actually come in pretty handy so far, and instead of seeing those 3 lines here, I'm just seeing the 1 line. And this is definitely going to come in handy down the road, so more on this to come. Alright, now I want to talk about the text box graphics and some updates I've made to the text in general in the game. So I don't know if you can see because it's really dark, but we have some graphics in the background of this text box. We've got a little border. I might improve on this because they're a little bit lackluster, but it gets the job done of a black background under white text so you can actually read it. But basically we have graphics back there, and in addition to that, when you collect a diamond, it actually says different things. And the cool part is it inserts the number of diamonds dynamically into the phrase that the main character says. So you can see each time I get a diamond, it says a different phrase, and it will actually, well, that time it said the same phrase, but it'll actually put the number of diamonds in somewhere in that phrase. So let's take a look at how that actually works after I put this back where it goes. Alright, so how that works is I've got an array of different, like I'm calling them hype words, but basically just an array of phrases, just strings, and inside of the string where the number of diamonds is supposed to be, I have a $sign. So in each one of these phrases I've got a $sign, and when I go to print this, before I print it, I just replace that $sign with the number of diamonds. So let's go down to where that happens. I think that's in maybe the update method. We'll see. Yeah, right here. So it's really simple how it works, and it kind of creates a cool little effect for your game where you can have a whole bunch of different phrases or a bunch of different random things that your character says or does, or just something to be make the game more interesting, and you can do it really easily with the strings replace method. So basically I'm getting the message randomly. I'm randomizing which message I get, so I'm just saying get a string from the hype words array at a random index, using this line right here to randomize what that index is. Then I'm setting the message equal to the message after you call the replace method on it, which just replaces any $sign characters with the item count, which obviously stores it, increments up every time you collect a diamond, and then you just write the text to the text buffer with the text tool. So we covered the text tool in the previous video, I think, or maybe the video before, so I'm not going to go over that. So really simple way to just add a whole bunch of phrases that you can have like dynamic control over just by using the replace method on, the string object in JavaScript. It's pretty handy. So now before I close out this section, I just want to go over how I drew these graphics real quick. So let's go into the initialize file, and basically I'm just defining my buffer. So I've got the text box buffer, so I'm saying set buffer. I'm going to name it text box, and I'm using this new method here called buffer, which is just a constructor that makes a canvas context. So if I go to the buffer.js file, we've got essentially a function that takes all the properties that you might want on a canvas context, like alpha, desynchronized, automatically sets image smoothing enabled to false, and it just makes a canvas context, sets the height and width. This way you don't have to do it all inline, which can look kind of messy. And then I just call this inside of my initialize function wherever I want to make a buffer. So when I set the text box buffer, I'm just going to call the buffer function. I'm going to make it 256 pixels wide, 32 pixels high, and it's not going to have transparency because I don't want to be able to see through it. and it's going to be desynchronized. There we go. This way it performs a little bit better, at least according to the docs. That's what it's supposed to do, perform just a tiny bit better. So we're going to set up the buffer here, and then down after we load our images up with the loader tool, we're going to load our images up, get our image, the text box image, which is, if we take a look, we can actually see what it looks like. I don't know if we're actually going to be able to tell. Yeah, you can kind of tell. That's the text box image. It's basically just 3 sections that I'm going to use to tile the text box buffer. And then we're going to get that image. And then down here, let's see, we're going to get the text box buffer, we're going to get the text box image, and we're going to draw the first part right here. We're just drawing the first part of the image, that left side, like that left kind of bordered side of that image. Then we're going to loop through the center. We're going to draw the center part of that image over and over again, all the way till the end, and then finally we're going to draw the end cap on it, the right side end cap on that buffer there. So that's basically it. Draw the text box graphics, have a couple new phrases that I added in with a dynamic piece of the phrase, which is pretty cool, and that's it for that. So now I want to talk about the updates that I made to the controller tool. Beyond wrapping it in a constructor function, as we talked about in a previous section, I just created a keys container, just an object that has the different keys inside of it. Before, these were constant local variables inside of this scope here, and I had too many functions that were like, you know, get P, get up, get left, get right. I didn't want all those functions, so what I did was I just replaced those individual local variables with a container that has the keys as properties of it, and then I have one function to get the key and one function to set the key. And other than that, all the changes to this were largely just aesthetic. That was basically the main change. Everything works exactly the same way, and it only warranted a few easy changes inside of the game states themselves. So like inside of the run game state, for example, instead of saying controller.getLeft, I'm saying controller.getKey left. And this just makes things more uniform, because every time I want to get a certain key, I just pass in the name of the key and it gets me the value, rather than having a whole bunch of different methods to get different keys, which kind of makes the controller file just too bloated and just had too much stuff in it. So I just want to tell you that quick update real quick, because I didn't want you to look at the file later on and be like, well, this is totally different. So yeah, that does it for the controller update. Now I want to talk about something that I learned recently while working on the project, mainly making videos for the project, and that is to not be afraid of making a change midway through the project if the thing you're changing is actually inhibiting you from finishing the project. And a lot of people probably have encountered like a feature that they really want to put in the game, or some kind of game mechanic that they really want to put in the game that just gets in the way of the overall success of the project. So for example, you're working on a particle system for your game when you don't even really have collision figured out. You know, aesthetics should probably come last, and if you're putting that sort of thing ahead of the overall project, you should probably reevaluate where your efforts lie and what you can do to change to get back on track with your project. For me, the thing I ran into was I was making videos. I wasn't editing them. I was just writing 100% of the code and recording 100% of me writing the code, and I thought that was going to be really cool because everyone would get to see everything going into the game. But as it turns out, nobody really wants to watch, you know, an hour-long video of some guy just like tapping away on the keyboard and running into errors and troubleshooting. And on top of that, it was actually taking away from the overall goodness of the code quality, because it's really hard to write good quality code when you're recording yourself and narrating. You know, you're thinking about like, is what you're saying making sense, more than actually thinking about like, is this the right thing to do with the code? And what happened was I'd have to go back and make refactoring videos to edit code that I had already written in a previous video, which just doesn't make any sense. So the thing to take away from this is, for me, to stop working on something if it doesn't make sense or if it's hindering you. Like if you have some kind of strict standard that says I'm going to work on my project every single day and you start getting burnt out, you should probably readjust and take that strict standard or that strict goal and say, this is actually hindering the project. Let me make a change so I can actually finish the project and have something viable that I can actually use in maybe like a presentation or a portfolio, or have like a cool game to like show my friends or something like that at the end of the day, rather than spending all your efforts working on a particle system or getting burnt out because you're just working too hard. So yeah, the takeaway: reevaluate things as you're working. Keep the main goal in mind. The main goal is just finishing. So finish it. And then if you have a cool feature you want to add it in later. Or if something else gets in the way, some extraneous thing like videos you're making to record your progress of the game, like a devlog, if that's getting in the way, you have to think, is that the most important thing, or is finishing the game the most important thing? And then make the appropriate changes.